Hey guys, it's Jensen. This is a screencast for sliding box. As you can see here, we are given this problem of 5 kilograms of the box with a force of newtons, 40 newtons going to the right. That's the tension. And so we are given here is the force diagram. What we can do is just make a force diagram. So in order for us to make a force diagram, we just do this. Newtons and weight. We can assume that they're all equal for now. But we're given to assume that, and we from the equation of the weight formula, which is 10 newtons per kilogram times mass, which is 15 newtons, which is going up and down, so they're equal. And from what we can get is it's either we can use the static friction. Since we know there's actually a friction, we don't know. We're given that static is 6 newtons, while sliding friction is mk, kinetic friction. If we actually put this into an equation where we get F is equal to 0.6 times 50 newtons, M times N, and the sliding friction is 0.4 times 50 newtons, we're given that 30 newtons of sliding for static, while for friction we're given the 20 newtons. Now for static, it's given to us that it's not supposed to be it's not supposed to be sliding, it's not supposed to have anything, meaning it has no acceleration. So if there's no acceleration and when it's not equal to 0, if it's not equal to 0, then we cannot use a static friction because it's not sliding. So what we can assume is that this box is sliding. So we are only given to use the 20 newtons. So we can say that 20 newtons is going to the left. And if we put this into a vector sum diagram, we are given that all of these are equal, and this is the total force of 20 newtons going to the right because it's sliding, because the friction is going to the left. And if we that's it. That we know that we can assume that here's acceleration is not 0. Here acceleration is not 0. Here we actually have some acceleration. So what we can figure out is that we're given that, and if we just subtract 40 newtons from tension and from friction, we get 20 newtons of total force. Now, what are we given here? What else are we also given? Now, we can also do the total force is equal to mass times acceleration because we're also given that. We can also look for the acceleration, which is 4 meters per second squared. How did I get that? Because I plugged in the numbers. I plugged in the numbers for 20 newtons, and the mass is 5 kilograms from this box, from here, from 5 kilograms. And so we're given that. So we plug this all in, we get 5 kilograms times 8 times 20 is equal to 20 newtons. Divided by kilograms, divided by 5 both sides, and we cross out 5 kilograms, so we have an acceleration of 4 meters per square, because like last time 1 newton is equal to 1 kilogram and times what meter per squared. So we're given now 20, so we just divide those two and we get 4 meters per squared. Now it's not even we're done figuring out what does this box represent. Next, what we need to do is now we can put this into another graph equation of acceleration. Now we can just look for the change in velocity. So if we move down here, we are given that acceleration is m over s squared, which is 4, and our time is 10 seconds. I forgot to give us this, that we also have a variable of t equals 10 in the beginning that I forgot. I'm sorry, I'm very sorry about that. So we have 10 is equal to 10 seconds. And so we're given 10 seconds. What we need to do is make the area, which is the area of the rectangle, which is base times height, which is base times height. So our base is 10 seconds, while our height is 4, which is 4 meters per second squared. So we multiply these together, variables cross out, and we get 40 meters per second, and that's our change in velocity. And at v0 over here, v0 is equal to when velocity is at 0 seconds, which is 0 meters per second. And so in order for us to get the final velocity, we have to add the change in velocity and the velocity at 0 seconds, which is 0 meters per second plus 40 meters per second, which will give us the final velocity of 40 meters per second. We go down, the only thing we can have left is the velocity graph. The velocity graph we're given here is a triangle, because we know that the velocity graph has to be a straight line in order for us. The velocity graph has to be straight line in order for us to have this equation. In order for us to have this equation to have acceleration constant, we must have a constantly increasing velocity. And so we do that. We do the formula, which is v is in which the triangle is half times base times height, and we can find the change in position. Now, in order for us to find the change in position, we have 40 meters per second, which is the final velocity, which is 40 meters per second, and the time is 10 seconds. We multiply those together, divided by 2, which is half times base times height, 40 meters per second times 10 seconds divided by 2. We're given 200 meters. So our our change in position is also 200 meters. Here we're given that all of these are our notes that we did this morning, and we are here, like what I said a while ago, is the static friction. This number were 40 newtons. We would have been cool, meaning if this 40 was 40 newtons, so that we can assume that this one is all equal, the acceleration is equal to 0, but it's not, because we want the static friction to not slide. We want the box to not slide. But if it was 40 newtons, we would have been cool. We could be using this equation because acceleration is 0. But it's not. It's 30 newtons. So what we're forced to do is kinetic friction, like we said. Going down based on surface roughness. Yes, correct. Here's my explanation a while ago for acceleration. Well, for finding acceleration earlier and putting it here in another graph, giving us a rectangle of 4 meters per second. Oops, oh god. 4 meters per second squared, which is 10 seconds. And we keep going down. I like the smiley face. And we're giving this equation, which is half times 10 seconds times 40 meters per second, which gives us change of position of 200 meters. And there you go. And it says here, surface does not provide necessary 40 newtons of friction to prevent acceleration. That's the static friction. That was the one I was explaining a while ago. And that's pretty much it. Good night.